Welcome to fourth module. In this, we will talk about system suitability testing. System suitability testing is a quick performance test you run before analyzing the real sample. It confirms that HPLC system is working properly, your method is validated, and the result will be reliable. There are various parameters used for SST testing. For this video, I will explain them using our website. Our first parameter is retention time. Retention time is how long it takes for a compound to pass through the column and reach the detector. Each compound has its own retention time under fixed condition. If retention time shifts unexpectedly, it could mean a problem with our mobile phase, temperature, or column performance. A stable retention time means your separation is repeatable and the method is working. Let's get to our software and check how we perform this test. In this page, you can see the chromatogram developed for each injection done by your instrument. Select your first injection, which is blank, and it has no peak. Pick next injection, which is your standard injection 1. Using zoom in, zoom out, left and right buttons, adjust the chromatogram peak to get a good view of the peak. Using the slider for line A position, adjust the position of line A such that you get the slider line to the apex of the peak. Here you can see the retention time based on the slider position. Click on Add to add the value. Similarly, add rest of the retention time values. After this, you can calculate the mean RT and percentage RST. Usually, a percentage RST of less than 2% is required. Our next parameter is tailing factor. Tailing factor tells you how symmetrical your peaks are. Ideally, a peak should be sharp and symmetrical. A tailing factor near 1 is required. A tailing factor more than 2 suggests tailing. Tailing can be caused by dirty columns, overloading, or poor sample preparation. Having a good peak shape means better accuracy and better integration. Let's get to our software to check how we perform this. Here, after selecting the injection of interest, adjust the peak to get a good view as we did before. After this, check the value of peak found and move the B line slider to the apex of the peak. The line slider value and the peak found value must match here. After this, also move the slider line A to the position of intersection of peak and the horizontal line. This horizontal line represents the percentage peak height. Below here, you will find the distance between line A and line B. Enter this value as value for A. Do the same by moving the line slider A to the apex of the peak and line slider B to the intersection. Then note the distance. After this, enter this value as value for B. Then calculate the tailing factor. Our next parameter is theoretical plate. Theoretical plate indicates the efficiency of column. Higher the plate count means better separation and sharper peak. You can calculate the theoretical plate using the retention type and peak width. A value greater than 2000 is generally considered acceptable for analytical column. Lower efficiency might mean the column is old, clogged, or incompatible for your method. Let's get to our software to check how we perform this test. Here, after selecting the injection of interest, adjust the peak to get a good view as we did before. Then move line slider A and line slider B such that both lines are at the starting and ending of the peak. Then record the value that you get as distance between line A and line B. Fill this value as peak weight in theoretical plate calculator. Retention time and column length are pre-filled according to the injection that you have selected. You can still change the data manually. After filling the values, you can click here to calculate. Next is relative standard deviation. This is used to measure the precision of multiple injection of a sample. In most systems, percentage RST is less than 2% and is required for consistent peak area. A higher value indicates variability. In this case, check the auto-sampler precision, while issue, or system pressure. Let's get to our software to check how we perform this test. Here, after selecting the injection of interest, adjust the slider such that you get the complete peak in between the line sliders. Then, click on Get Peak to remove any other unwanted peaks. Do this for all other injection and then click on Show All Retention Time and Area. Note the area and close this. Back here, click on Retention Time and Area Calculator. This will open a calculator that you can use to calculate the standard deviation and relative RST. You can manually input the values or use autofill to automatically fill the data. Then click on Calculate to calculate the result. Our next parameter is signal to noise ratio. Signal to noise ratio tells you how visible your peak is above the baseline noise. For a quantitative work, signal to noise ratio of greater than 10 is usually required. For limit of detection, signal to noise ratio of 3:1 is acceptable. A low signal to noise ratio can result from dirty detector, poor mobile phase preparation, and unstable baseline. Let's get to our software and check how we perform this test. Here, after selecting the injection of interest, adjust the peak to get a good view as we did before. Move the line C position slider so that you can measure the height of the peak. For calculating signal to noise ratio, we need two values. One is your main peak height and second is your baseline noise height. Here you can see the height value of main peak. Enter this value in your SNR calculator as peak height. Then also find the height of noise. Again, enter the value in the calculator. Click here to calculate your signal to noise ratio. Troubleshooting SST. If one or more SST parameter fail, do not continue with your sample analysis. Check for issues like air bubbles present in the system or a usage of old mobile phase, column degradation or contamination, auto-sampler error, or incorrect injection volume. Once the issue is fixed, rerun the SST parameters. Document everything. Running SST before every batch or sequence is a required process.